Okay, here's a video going through the first version of the exponential and logarithmic exam, just in case you had any issues with this. This was lessons 65 through 73. So if you are having trouble with any of these and you'd like a bigger explanation, 65 through 73, that's where you can find the full lesson recaps. Now, start with number 1. And if I go too fast, just slow down the playback speed, or you could always, jump back in time to watch it again. The expression log 8 of 64 is equal to, now this is a what power function, or you could also think of it like this. Log base 8 of 64 is equal to what? Do the swoop. 8 to the x power equals 64, and well, 8 squared is 64, so it's 2. The expression log base 5 of 1 over 25 is equivalent to, I can do the same exact thing. Log base 5 of 1/25 is equal to x. I can use the swoop. I get 5 to the x power equals 1 over 25. And now here's the rationale. 5 squared would be 25. But I need to put a 1 over it. A negative exponent puts a 1 over it. Makes it its own reciprocal. So my exponent is going to be -2. The solution set of the equation. Well, I would love to solve this. I would love to solve it by making the bases equal. 9 is equal to 3 squared. What's that equal to? It's equal to 3 to the x squared plus x power. Now, both bases are equal, so I can cross them out and forget about them. X squared plus x equals 2. Now I have an equation to solve. I'm going to do that by subtracting 2 on both sides. I get x squared plus x minus 2 equals 0. This is 1x, so two numbers that add to 1 and multiply to -2. So it's going to be x plus 2, x minus 1 is equal to 0. That's just double bubble factoring. And then my answers are -2 and +1. And that's choice 3. What is the value of x in the equation? So here I have two different bases. 9 is 3 squared and 27 is 3 cubed. So I can change those both. 9 becomes 3 squared. 27 becomes 3 cubed. And now they both had these original exponents too, though. There you go. This had a 3x plus 1. And this had an x plus 2. What do we do when we have a power raised to a power? We distribute because we're multiplying. So you can think of it almost like this. 3 raised to the 2 times 3x plus 1. And on the right-hand side, same thing. 3 raised to the 3 times x plus 2. I can distribute those. And I get 3 to the 6x plus 2 is equal to 3 to the 3x plus 6. Cross out both the bases because they're equal. I get 6x plus 2 is equal to 3x plus 6. And now I just have to solve for x. Minus 3x, minus 3x. We get that 3x plus 2 is equal to 6. Minus 2 minus 2. I get that 3x is equal to 4. And divide both sides by 3 to get x by itself. And x is equal to 4/3. So my answer is 4. Question number 5. The amount of money in an account can be determined by the formula A equals PE to the RT, where P is the initial investment, R is the annual interest rate, and T is the number of years the money was invested. What is the value of a $5,000 investment? So $5,000, that's my principal investment. After 18 years, so 18 is going to be T, that's time. And they even told me the interest rate. So all I have to do is plug these in. A equals P E to the 4% is 0.04 times T, which is 18 years. I can plug this right into my calculator. Once I plug in the 5,000 for the P, A equals 5,000 times E, 0.04 times 18. I'll show you how to plug this into your calculator. 5,000 times E raised to the 0.04 times 18. Enter. 10,272. So my answer is 4. For question number 6, 7 to the x is equal to 3, then x is equal to. So I just want you to solve for x. Solve for x. So 7 to the x equals 3. Log both sides so you can bring down the x. I get x times log of 7 is equal to log of 3. Now to get x by itself, I need to log 7, or divide by log 7 on both sides. The log 7 on the left will cancel out, the one on bottom and the one on top, and I'm left with x is equal to log 3 over log 7. What is the solution to this? They decide, if you look at the answer choices, to use ln instead of log. One is not better than the other. They're the same thing, essentially, in this case. So, what is the solution to this? Well, if I want to get at that x, which seems to be the goal, first thing I'm going to have to do is divide by 8 on both sides to isolate the exponential term. I'll get that 2 to the x plus 3 power is equal to 6. I want to be able to get the x down, so I'm going to have to log both sides. Log that and log that. I suppose maybe I'll use ln, just so my answer looks like theirs for your sake. ln and ln, which now allows me to bring down the exponent. So I get x plus 3 times ln of 2 is equal to ln of 6. Get the x by itself, so I'll divide by ln of 2 on both sides. I get that x plus 3 is equal to ln of 6 over ln of 2, and then minus 3 to get the x by itself, giving us this, which is choice 1. So that's what x is equal to. Question 8. The product of these two. Product means multiplication. Product means multiplication. So when we multiply these, 3 times 2 is 6. X to the 5th times x to the 4th. When we multiply things, we add their exponents. So 5 plus 4. And that makes it 6x to the 9th. Answer choice 3. 9. This expression is equivalent to, I'm going to take the numbers first, 12 over negative 3. I'll handle the w's. You can think of it one of two ways. You can think of it as moving the w up, or you can think of it as subtracting. It doesn't matter either way. You're going to end up with w to the 6th. Either way, you're going to end up doing 9 minus 3. So you're going to get w to the 6th. Then y third and y third is going to cancel out. 12 over negative 3 can be simplified in the calculator into the number negative 4. So we get negative 4w to the 6th 1. Next question, 10. The expression 6x cubed y to the 6th all raised to the 2nd power is equivalent to. So this is just a little reminder of what you do when you have an exponent on the outside. You're going to distribute it onto all terms. So I get 6 squared. When I'm distributing this, I'm multiplying because each term has a power raised to another power. When you raise something to 2 exponents, you're multiplying them. So x raised to the 3 times 2 power, x to the 6th. Y is going to be raised to the 6 times 2 power, so y to the 12th. Okay, so I'm going to get 36, x to the 6th, y to the 12th, which is option 1. Now let's move on to the free response. The goal is to solve for the value of a, right? So I'm not sure, it seems like there's an x and an a in here, so let me just do what I know I can do. I know I can divide both sides by 3. That's not a problem. X raised to the 2a is equal to 1. Now what power would make something equal to 1? 2a must equal 0. Because x to the 0 would be equal to 1. So if 2a must equal 0, 2a equals 0, divide both sides by 2, 0 divided by 2 is 0. A must equal 0. If you wanted full credit, you needed to show work at least this elaborate. You can't just tell me that a is 0 because you said so. Explain how negative 8 to the 4/3 power can be evaluated using the properties of rational exponents to result in an integer answer. The properties of rational exponents. This is what we mean by that. So negative 8 to the 4/3 power means this. This right here is a power, and the divided by 3 is a root. So if I put down the cube root first, and I put the 4th power on top, we can say that let me write this a little bit neater. The cube root of negative 8 is negative 2. Then we can raise it to the 4th power. Which is 2 times 2 is 4, 8, 16, positive 16. This is an acceptable answer. You could write more, but this is full credit because I'm explaining that a 4/3 power is equal to a cube root and a 4th power, a 4th exponent. So you need to explain what both of those sort of mean in the context of the question and show that you know that they're equivalent to radicals. Now, number 13. I'm solving for n. So if I'm solving for n, the first thing I'm going to have to do is get rid of the 10 over here plus 10 here. Because he's on the outside, it's easy to get rid of. So I get that 16 is equal to 64 minus 2n raised to the 4/5 power. Now, if I want to get in at that n, I need to get rid of the exponent first. I'm trying to sort of break my way in, you know? I'm trying to get rid of everything on the outside to make my way in so I have nothing but the n. So the way that I get rid of an exponent that I don't like is raise both sides to the reciprocal power. So 4 over 5 gets flipped into 5 over 4. Now here's why these cancel out. 4 times 5 is 20. 5 times 4 is 20. So 20 over 20 is 1. We don't need to write a 1 exponent. It doesn't change the value of anything. So on the left-hand side, I get 16 to the 5/4 power. Let's see what that's equal to. And that's equal to 32. So I get 32 is equal to 64 minus 2n minus 64 on both sides. I get that negative 32 is equal to negative 2n. And I divide both sides by negative 2 to get that n is equal to positive 16. On to the next question, number 14. The amount A in milligrams of a 10 milligram dose of a drug remaining in the body after t hours is given by the formula A equals 10 times 0.8 raised to the t power. Find to the nearest tenth of an hour. So find, we're talking about hours, so we're looking for t. They're saying solve for t. They said that, like, literally right here, okay? So how long will it take for there to be half of the drug dose left in the body? Now, if I'm looking at this equation, I know I have to find t. So therefore, I must know what A is. I have to. Otherwise, I can't solve this. So I must know this somewhere. So let's see. They want half of the dose to remain. Half the dose. What's the dose? 10 milligrams. Half of that would be 5 milligrams. So the equation as it stands, that's what A is. So we get 5 is equal to 10 times 0.8 to the t, and our goal is to solve for t. So I'm going to divide both sides by 10. I get that 0.5 is equal to 0.8 to the t power. I would love to be able to bring the t down. The only way I can do that was with a log. So I'll log both sides, and that'll allow me to bring the t down. I get log of 0.5 is equal to t times log of 0.8. Now to get t by itself, I divide both sides by log of 0.8. And I just need to evaluate this with my calculator. Log of 0.5 divided by log of 0.8. Log of 0.5 divided by log of 0.8. Enter. 3.106. So t is equal to 3.106 hours. Let's see what they want me to round to. Nearest tenth, so only one decimal place. 3.1 hours. You always want to make sure you've rounded correctly before you box an answer. Question 15. Graph the inverse. So the inverse requires us to switch x and y. It means we have to find different points. Switch x and y. So let's find some points on this. Negative 5, 1. That's this point right here. I'm only going to find a couple because I don't really need to find a lot. 1, 2, 3, 4, 5, 6, 7. So this point right here is 1, 7. And let's grab this one over here, which is negative 9, 5. Now all I need to do is flip those. So negative 9, 5 becomes 5, negative 9. Negative 5, 1 becomes 1, negative 5. And 1, 7 becomes 7, 1. Just switching the x and the y values. Now let me graph those points. 5 over, 9 down. That's one point. 1 over, 5 down. That's my second point. And 7 over, 1 up. And it's going to go right here. Now if you have a ruler, you can make this look really nice, but for me, I can cheat with the digital straight edge. Let's go through that point here. And let's go through this point here. And that is a perfectly acceptable graph of the inverse of the given function. It's a reflection of the line y equals x. Okay. Find the inverse of the following. So, like I said in the last question, inverse means x and y are going to switch. X becomes y, and same thing for here. X is going to become y, and y is going to become x. So we switch them. Now find the inverse. So let's switch them to start. I have x is equal to log base 5 of y plus 10. And now I just need to get y by itself. So to get y by itself, I'm going to get rid of this 10 first. Minus 10, minus 10. I get x minus 10 is equal to log base 5 of y. Now I wish this wasn't in logarithmic form anymore. I wish that y was just by itself. So I'm going to try to use the swoop. I'm going to move the x minus 10 over, because I like my log to be on the left. And now let's try to swoop it. We'll start here. 5 to the x minus 10 equals y. 5 to the x minus 10 equals y. And that's actually, y is all by itself now, so we've succeeded. That is the formula. Once y is by itself, you're good. That's the end of the question. Now you've found the inverse function. We don't need to solve for a specific value or anything, just the inverse function. And lastly, question 17, find the inverse of the following. I'm going to switch x and y to begin with because that's what they want me to do. That's what the word inverse tells me to do. X is equal to 3 to the y plus 8. Now I need to get y by itself, so let's get a move on here. I'm going to subtract 8 on both sides to get that away from the 3 to the y. I get x minus 8 is equal to 3 to the y. I would love to be able to bring that y down, so in order to do so, I need to log both sides. And now y can come down. So I get log of x minus 8, which should be in parentheses, is equal to y times log of 3. Now to get y by itself, we divide both sides by log of 3. And you could say that y is equal to this. But I taught you in class how to simplify this a little bit more. I said that if you had something like this, let me rewrite. Y is equal to the log of x minus 8 over the log of 3. I told you that you can make this into the base, talking about this, and make this into the subject. So essentially you can smush these two together and you can turn it into log base 3 of x minus 8. So the top stays normal and the bottom goes to the bottom. So think of it sort of like they stay in the same position. We just smush the logs together almost. Okay, so that is the perfect full credit answer. Y is equal to log base 3 of x minus 8. Okay, and that's it. If you have any questions, please feel free to ask me in class, office hours, morning, off periods, whenever you see me.